All right, so 8.2 is all about arithmetic sequences in series. So if we add the same thing or subtract the same thing every time, we call that a common difference. So if you look at number 1, we're just going to tell whether it's arithmetic or not. Let's see, I'm adding 4 here, but then I'm adding 5, I'm adding 6, so this is not arithmetic at all. But if you look at number 2, I'm subtracting 3, and then subtracting 3, and then subtracting 3, so this one would be arithmetic. And if you're unsure, you can always take a term and subtract the one in front of it. So 1 minus 4 is negative 3. So I'm subtracting 3 every time. Or negative 2 minus 1 is negative 3. So we kind of have a rule for arithmetic sequences. So it involves using the first term plus the term number minus 1 times d. When you write the equation, you always have places for the a1 and the d, but n is going to remain n and a sub n is a sub n, unless you're trying to find a certain term or you're trying to figure out what d is, then it really just stays the same. That would be your rule. This n pairs up with this n, and since this is the first term, that's why this is a 1. So if I had put the fourth term here, this would be a 4. So we're going to write a rule and then find a sub 15. So I see that I am adding 3 every time. Now we learned in 8.1 that you can do this equation a different way, but because sometimes you have to use it, we're going to use the formula to do this. So I'm going to be plugging into this formula right up here. So I have a sub n is equal to. Now I have to plug in my first term. My first term is 7 plus n minus, now since I used the first term, this stays a 1. And then I know that my difference is 3. I'm adding 3 every time, so I'm going to multiply by 3. At this point, it's nothing but simplifying. So I need to distribute my 3 through the parentheses. That gives me 7 plus 3n minus 3. So I have 2 like terms to put together, and then I'm going to put this in standard form. So the 3n should be at the front, and then 7 and negative 3 make 4. So there is my rule. Then it wants the 15th term, so all I'm going to do is plug 15 in just like we did in 8.1. So 3 times 15 plus 4, so 3 times 15 is 45, plus 4 is 49. Now this is the only one I'm actually going to go through plugging the 15 in. We've already learned that in previous lessons, and so for the sake of time, now you know that you just plug that in. All right, so here I see that I am subtracting numbers because they are going down. So I know that my common difference is going to be a negative. So every time I am subtracting 7. So my common difference is going to be negative 7, and my first term is 15. So my rule would be a sub n is equal to plug in the first term plus n minus, since this is the first term, this is a 1, times my common difference of negative 7. So now same process applies. I will simplify and get it all in the correct order. So I'm going to distribute this negative 7. So I have 15 minus 7n plus 7. Combine like terms, put it in order. So negative 7n, and then 15 and 7 make 22. And then to find the 15th term, again, you would just plug 15 in for your n. All right, now sometimes they don't give us the first term, which is fine. We can use this 19th term that they gave us. But they did give us the common difference. We always have to have that. So a sub n is equal to, now normally we plug in the first term here, but we don't have that. So we're going to plug in the 19th term, which is negative 45, plus n minus, now because this isn't the first term anymore, this isn't going to be a 1. It should be 19 because this is a 19th term, times my common difference of negative 3, and then the process is exactly the same. I'm going to distribute negative 3 So negative 3 times n is negative 3n. And negative 3 times negative 19 is a positive 57. Combine like terms and put in order. So we have negative 3n plus 12. So same thing on number 6. Instead of putting the first term here, we don't have that. We're going to put the 12th term. Plus, and then n minus. Now this is no longer the first term. This is the 12th term. So I'm going to put a 12 there. Times my common difference of 6. So I have 52 distribute the 6 plus 6n minus 72. Combine like terms and put in order, and that gives you 6n minus 20. Now, on 7 and 8, they don't give you d, and we need that. So we have to plug in for every part of our equation except for d, because I don't know that. So on the outside here, I'm always going to put whichever term is in the biggest position. So this is in the 7th, and this is in the 26th. So I'm going to put 93 out here. And then in place of where I normally put my first term, I'm going to put the 17. Now the reason I did that is because in this parenthesis, it's normally n minus 1. So if this is a bigger term, then this one I can avoid a negative. So this is the 26th term minus the 7th term times d. Now I just need to solve for d. So I'm going to subtract 17. 93 minus 17 is 76. And then 26 minus 7 is 19 times d. So to solve for d, I divide by 19. So d is 4. Now I can choose to use either of these terms. It doesn't matter. I'm just going to use the 7th term and do what I did on 5 and 6. All right, so a sub n is equal to 17 plus n minus, this is the 7th term, times 4, and then I'm just going to simplify. So that gives me 17 plus 4n minus 28. Put it in order, combine like terms, and we get 4n minus 11. Same thing over here. We have to figure out what d is because we always need d. So I'm going to use the bigger position on the outside. So negative 8. And then inside, where my first term normally is, negative 43. Plus, in the parentheses, this is the 12th term minus the 5th term times d. And now I solve for d. So I'm going to add 43. Negative 8 plus 43 is 35. And then the 12 minus the 5 gives me 7d. Divide by 7. So d is 5. And then again, you can choose either of these terms. I'm just going to use the 5th term. So I plug in to get my equation. So I have negative 43 plus n minus, this is the 5th term, times d, which is 5. And then we're just simplifying. So we have negative 43 plus 5n minus 25. So a sub n is equal to 5n minus 68. All right, so to find the sum of the first however many terms they give us, in other words, this one is 1 to 20, so the first 20 terms. All right, if this is the sum of the first 20, then this n will be 20. I always need the first term, and I always need the last term, and then I divide those by 2. So I need the first term and the last term. So to find the first term, I'm just going to plug 1 in. So 3 times 1 plus 7, which gives us 10. I also need the 20th term because that's the last term in this series of numbers. So 3 times 20, which is 60, plus 7 is 67. Now I'm ready to plug in. So the sum of the first 20 terms is equal to 20 times the first term plus the second term divided by 2. Now you can plug this whole thing in all together at the same time, and you are going to get 770. So if I took all the first 20 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I plugged all those in, and then I added them up, I would get 770. So this is going from 1 to 18, so I need to find the first term. So 6 times 1 is 6, minus 2 is 4. And then the 18th term, so 6 times 18 minus 2 gives us 106. So the sum of the first 18 terms is equal to 18 times, add those two numbers together on the top and divide by 2. Plug all of that in, and you will get 990.